on. I guess I should turn the game sound on too. And then I can transition over here to the talking screen, and now we can actually say hello to everyone. Yay! First try, no issues. How are you doing,
Uh-huh.
Mama?
I'm doing all right.
That's good. We
There we
almost
go. It
had
popped up.
we almost had issues with Mum's computer as well as my upload speed for some random reason. But it was
Well,
the
we did
same.
have an issue with mine, but it
Yeah,
was easily resolved.
yeah. Um, so that was good. That we solved that quickly. Yeah, it's most likely a problem with the battery, and it's not keeping a setting on for some reason. So if the power goes out, then the computer doesn't want to boot properly. So it's either the fact that the battery it doesn't work, so the laptop only works if it's plugged in, and so if the power goes out, then it's like, oh, I have no power, so let me forget everything I'm supposed to know. And then if it's not just that, then it would also be there should also be a little battery inside the laptop that keeps that particular set of settings on. Although now that I'm thinking about it, that might be a bigger issue if that battery goes out, but maybe I'm wrong. I'm not sure. Maybe people who know computer science, or I guess not necessarily computer science, computer repair, more would be able to give a more accurate statement about that. Uh-oh. Could be streaming.
Looks like you're dropping frames again.
Oh yeah, I am dropping frames again. Although the bit rate's the right number. Okay, percentage is going down. See what happens. Okay. It was just myself being silly now. Yeah, alright, so battery stuff for Mama's laptop, internet stuff, caused a delay on my laptop. But yeah, we have gotten that stuff fixed for now. So, yeah. How is the weather on your side, Mama?
Cold.
Yeah,
It was a little snowy, but
it was. It did some snowing here as well, and the roads were quite slippery as I was doing grocery shopping, so that was a little frustrating. It took a while to get home, and what's the other thing? Oh, it was also very icy, so it would it like the snow immediately like turned to ice, so it was like worse than just simply having a little bit of snow on the road that made it a little bit of
oh,
slipperiness. So it's very unpleasant, and I need to replace my windshield wipers apparently because there's just like this section on my windshield that's not being wiped by the wipers.
yeah.
I don't know
Well,
how much. Go ahead.
Oh, yesterday morning I was scraping the frost off my windshield, and my scraper snapped.
Oh no, that's awful. Yeah, I had to
Well,
just. Oh, go
fortunately,
ahead.
I've got another one in the car, a little
Mhm.
one. This was on my big telescoping one,
Yeah.
but I was able to scrape it off because I have another one, a little one in the car. So,
Mhm. I just got some gloves. I should probably have had gloves for a long time. But the I had to scrape my car off as well yesterday. I guess not yesterday. It was today. Since today was Monday. But I had to scrape it off another day. Um, maybe that was last week. I don't remember. And it was just like a thin coating of ice rather than like frost or just a really light dust of snow. It was very upsetting. Took like 10 minutes to do the front and back windshield and the windows. So, anyway. Yeah, not as bad as the windshield or the scraper snapping though. That is very frustrating. But yeah, I don't have anything else to say about the weather or grocery shopping or batteries. Do you have anything else, Mama?
no. I mean, it was just the scraper part that snapped. It was the whole telescoping thing with the broom on it is still fine. So,
Hmm. Yeah. Does yours have grips on like both sides of the broom scraper tool thing? Because mine has grips on only one side, and it's like really frustrating to use both of my hands because like one goes on the grip and the other goes on metal, or they both go on the grip, and it's just like really awkward to like hold this gigantic thing from like the end that I'm scraping on.
well,
Um,
yours is I think is like mine. The telescoping
mhm.
to like 6 feet.
I don't know if it's six
Maybe,
feet, but yeah,
maybe
telescope.
not that much, but yeah, it's probably the same as mine
Mhm.
because I think I got it at the same time I got mine.
Maybe I'm not sure. I think I got mine at Aldi.
Oh,
I could be wrong though.
maybe.
I could have gotten it at Kroger or somewhere else.
Well, because I had gotten two. Well, maybe I had gotten one for my car and one for what had been your car at the time that
Mhm.
became Josh's car. So I don't know
Yeah.
because that would have been probably at about that same time.
Oh yeah. Then if that was in that car, that probably ended up in Josh's
Yeah,
inventory.
yeah, because that car ended up being with him. So
And most of the time, the stuff that like goes with the car would have just stayed with the car. Like I wouldn't have been upset that that went with the car. So
well, and then there would have been another with Granddaddy's car that became your car, and so it would have become yours too. So
mm, yeah. Although it doesn't matter. It might have gotten lost, or I didn't like it very much, so I replaced it, or something else. I don't know.
who knows?
Yeah, who knows? But you know what I do know? I do know
It's time
Sudoku.
for Sudoku.
Yeah, exactly. So let's go ahead and hop over to our first puzzle tip for today. And take a look at One Line, question mark, by Zoro-ish. Normal Sudoku rules apply. Adjacent numbers on a green line differ by at least 5. Adjacent numbers on an orange line differ by at least 4. The endpoints of a gray line sum to 5. The endpoints of a red line differ by at least 5. Cells with a circle are odd, and cells separated by an X add to 10. Not all X are given. Okay. So, those two sum to
The
5.
end.
Yeah. So that basically just means that those are small digits. That makes that a 5. And actually, it's a 5 just automatically because of that. And that one and that
Well,
one are low. So these end up all being high because the two endpoints of the red line have to differ by at least 5. And of course, these are all high digits as well. Orange was differ by 4, so that can go up to 5. But I guess if these two differ by 5, then we can't put a 5 there, and that makes that a high digit. So is that one. These two is low digits. So if that's low, then that goes over there to high, low, high. And I just remembered the copy and paste that I can do.
place a
There,
5 in
there.
box 5.
That's true. Those. This isn't necessarily a low digit, because this can be a 5.
Yeah.
And actually, if this is a 5, those could both be 1. Which, I guess... Yeah, so this can be any of the digits. Well, I guess the only way it's a low digit... Or excuse me, the only way it's a high digit is if this is a 5 and that's a 9. So this ends up being 1 through 5 and 9. Oh, except it's on a green line, so that can't be a 5. But it can still be a 9, making that a low digit. Possibly. Okay. What other things to consider? Well, if those aren't 5, then suddenly that one is, which makes 5 up there, but that's okay. Alright, I am going to go ahead and do highs and lows. I tried to avoid it, but it seemed a bit silly. So this one makes that a low and that a high.
Alright, row 2.
Why can't I copy and paste? Row 2.
Yeah, needs 3 high digits, but only 2 high digits can go in box 3. So that one's a high digit in box 2.
One, two, three, 4. Actually, the fact that all of that isn't a 5. 5 ends up being one of those two. Okay. I guess what I should do is look at these two and note they can't be 4.
Right.
None of these can be 4, so that is. Which makes that a 9. It's not. Takes 4 off of there as well. These add to 5, so this not being 4 means that isn't a 1. Okay. This and this can't be 6, so that's a 6, making that a 1. And that a 1, so that's a 4. Neither of those is 1. One of those is a 7, so that's a 2. That's a 3. Which I think forces that to be 7 and 8. 3 is out, 8 is out, 1 is out, 6 and 7, 1. Those can both still be 4. This being a 4 forces that to be 9. That's not 9, that's not 9, that's not a 1, 6, 9, 6, 9, 1, 3, 4, 1. Okay, these two 9s make that a 9. Meaning this is now a low digit and a high digit. This one is not guaranteed to be a high digit. That could be a 5. And then those are both 1s.
Center digit of box 3 is either 3 or 7.
This can still be a 4, which would make that a 9 and that an 8.
Okay, the endpoints of red lines differ by at least 5. Box 3, that's going to be 7 and 2.
That makes that a 3 and a 4. So that's a low digit. And what? We have 8 and 6 left?
No,
that's a 7.
no.
Yeah, you were noping on this being an 8, right?
Yes.
Okay, cool. Yeah, that was just me mistyping because I knew that the 6-8 thing made that not an 8. What's left over in this row? 2 and 6, and 3 and not 5. 5's been there for a while.
3 and 8.
And 8. 7, 7, 7, not a 3. Well, I guess I can just simply go all of the digits there. 3 and 7 is off because of that. 9 and 1, 4 and 6. Although I'd like to know which one's high and which one's low. Okay, this being a 2 means neither of those is 6. Oh, this one can't be a 6 because then it would be surrounded by 2 1s.
The other one can't be a 6 either. That one, that's the box 5 cell 9 can't be a 6 because it would be. Oh no, never mind.
Yeah, this would be a 1 and this one a 2.
Yeah. Because that's orange.
Yeah. So, like, this one can still be a 6, because that can still be a 2. And this can still be a 4, because that would be 9 and 8. This cannot be a 4, though. Those would both be 9s, neither of which can be because of the 9 there. So that's a 2, meaning those aren't. I guess the other way of looking at it is one of them has to be a 7, so it can't be larger than 2. 6 has to be one of these two, so that's 2 and 6 here. And now this cannot be a 6, because those would both be 1s. So that's the 6, that's a 1, that's not a 1, that's not a 1 or a 9. 6 and 4, 1 and 9. 2, 8 pair makes that 3 and 7. Not a 1. 3, 8. Did this the same mistake as before. 9 there, 2 there, not a 2, that's an 8. Apparently it's 7 and 9. 7 is next to 3.
Column 3 has 1, 2, and 5 left.
That's a 1, because that can't be it. It's the 6, 7. Column 3, you said 1, 2, and 5. Apparently a 5 there, a 1 there, and a 2 there. Whoa.
3 in column 7 can be placed.
Neither of those two. 2 in box 9, because these two, that one,
Yeah.
it had to be up here, not that one, because it can't be there.
Which
so
resolves the
2.
X. Row 4 needs a 9 and a 4. Column 4 needs a 7 and 8.
This is 4 and 5.
4 and 5.
What's over in this row? 5, 6, 8, 9. Those two aren't 5. This one also isn't 6 or 8. So that's a 9. That's a 4. That's a 9. None of those is not an 8, not 8 or 9. 5, 6 pair places an 8. So red, it's 2 9s. 4s are low, so that's blue. This one's not an 8.
1 can be placed in box 6.
5, 6, and 7. 5, 6 pair makes that a 7. 7 here is those two and those two. So that's the only spot available. This has to
Column
be a 4.
7. 5, 9 is resolvable.
6 over here. This is 5, 5, and 6. 4 and 6. 4 and 6. 1, 2. I need a 3. It's neither of those two, so that's going to be a 3 there. I also need a 4, which is on top. A 9 here, and an 8 there to finish the puzzle. Nice! Alright, and Logic Masters Germany, maybe? Probably looking for Zorro-ish. Try one line. Nope. Nope. And alright, well, I couldn't find that. So hopefully it's not on Logic Masters Germany. But that was a good puzzle. Alright. Next puzzle is going to be Inception by I wanted to say this is some Manta. Yeah, I think some Manta makes a lot more sense than Sumanta. Because I think it's a play on Samantha. I could be wrong. And then Anu is in parentheses there. So normal Sudoku rules apply. In the thermometer shapes, digits must strictly increase from bulb to the tips. The sum of the digits in each cage is given at the corner of the respective cages. The digits on a black lines must strictly be in between the digits connected on the attached empty circles. The gray circles contain odd digits. So, okay, great standard thermo rules and lockout lines. So if I were to put a 3 and a 6 here, then this would have to be 4 or 5. So clearly that doesn't work, but that's the example there. All right, then where do we start?
Might also do the odd circles.
That's true. They're 3, 5, 7, and 9 because they all see the 1 in the middle. And I guess these two become 2, 4, 6, 8. Twelves have to be 3 through 9 without 6. But I think there's 3 different possibilities that go there. So that's not helpful. Yeah, 3, 4, and 5 pair with 7, 8, and 9. So while we know 1, 2, and 6 are on the outside, it's not particularly helpful. One and 9 end up not in here.
And they can't, well, in box 9, they can't go, obviously, in the 4 cells that you mentioned, and it can't go in cell 1.
Yeah. It's also true in boxes.
Well, except 1 can go in,
yeah.
but not 9.
Yeah. This does look like it might be a Vistamethel ring puzzle.
Well, there are no ones.
Yeah, 1 can't go in there. Okay, I'm gonna go ahead and do the Vistamethel proof real quick. If I think about the 4 corners, the 4 corner boxes, that's 4 sets of the digits 1 through 9. I can also highlight these 2 columns and these 2 rows. Note that their intersections have to be doubly counted. I'll mark those in green. And so, if we consider the 4 red corners, that's 4 sets of the digits 1 through 9. And the blue sets are also 4 sets of the digits 1 through 9. And if you consider those in 2 separate buckets, you put all of the numbers in there. If I take this tile on it, let's say it's a 6, and I take that 6 out of both of the 2 buckets, those 2 buckets are still equivalent. They both still have the same numbers in them. If there's 4 sets of the digits 1 through 9, less a 6. So they're still equivalent. I can do that with any of these tiles that are both red and blue. And both the red and blue sets are still equivalent. These 4 corners that are red, green, and blue, well, the green just means it's in blue twice. So if I remove green and red, then it removes each corner from the blue set once and the red set once to keep the sets as being equivalent. And so, regardless of what type of Sudoku puzzle you're doing, you are always going to have it be such that the 4 corners that I have highlighted in red those 16 cells will be the exact same cells or digits that will be in the blue ring around the middle box. And what we can do with that information, because of the lockout lines and these 12s, is know that there are no 1s anywhere in the blue fistimethyl ring. So that means that all of these are minimum 2, 3, 4, 5, 6, and 3, 4, 5, and 6. And, well, what that means for these is that they have to be 6, 7, 8, 9. So that takes 7 and 9 out of those two, making those a 3-5 pair and a 2-4 pair here. I don't know. Well, I mean, 6, 7, 8, 9 is forced regardless. So this is going to be 5, 7, 8. 5, 6, 7. 4, 5, 6, and 4 2s are going to go 2, 3, 4, and 5. Now, what is important to note is that
Well, in box 7, the 12s, they contain 2 low digits, or 2 digits from 3 through 4, 3, 4, and 5.
Yeah.
And 2 from 7, 8, 9.
If there's a 9 on there, that means the 9 has to be one of... Well, it doesn't have to be one of those two. It could be one of those two. Because I can put the 9 on the inside just fine.
Right.
I guess my question is, I know that I can only ever have 1 5 in this set on the bulbs. Because it's going to go 5, 6, 7, 8, 9.
Right.
Could I possibly have 2 of the smaller digits, 2, 3, or 4? Could I have 2 2s? Is the question I want to ask. So could I put a 2 here and a 2 there of those two? I can't say that I couldn't. Or at least, I don't think that I couldn't logically
rule it out yet.
Yeah. Because I know this line here is really important. Because it's going to be 6, 7, 8, and 9. So somewhere there's going to be a 6, which is going to force that whole line to go 6, 5, 4, 3, 2. But it might be 6, 5, 4, 3, 2. I guess since I know that's going to happen somewhere, let's just place it right here. 6, 5, 4, 3, and 2. What impact does that have on the rest of the things? So I get 2, 3, and 4 here, which means that one of my lockout lines is going to have a 1 on it, Because the only place I can put it to is on the lockout line. Can't put it in the 12s.
Well, okay, in column 4, the 5, 6 takes 5 and 6 out above it.
4, 7.
And up one more. Well, I wouldn't worry about the right-hand side, but on the left, that becomes a 3, 4.
Okay.
So to the left of that, that's now 2 or 3. Well, it can't be 3 because of the 3 at the bottom. So that would have to be a 2.
Okay. 5, 6, 8. 7, 8, 9. These are both 7, 8.
Well, and in the center, that can't be a 7 because of the 4, 7 pair.
And this is, well, this would have to be an 8 going into a 9. So 9s are out because of the 4, 7 pair. These are actually a 2, 3 pair automatically because of everything else that's going on in here. I can't put 2 or 3 on these. So that takes out 2 and 9, and then 3 and 8. And actually makes these 1, 2, 3, 4, 5, 6,
8, 9
pair. But where can I place a 9? Hold on. I'm going to leave those. I can't put a 9 on the lockout line.
Well, one of the 9s has to be in the 12. Yeah.
So we're going to have a 9 and 3 pair in here. Which actually forces this out. But more specifically, I cannot place another 9 on these two. So that's going to take out 8, 7, 6, and 5. Now, 8 I can put in a lockout line, so that's not going to be a problem. This can't be 3. Means that goes up. So 2, 4, 5, 6, 7. 9, 8, 7, 6, 5, 2, 4, 5, 6, 7. So then okay, I know that this one isn't 6 going down. What if this one was 6 going down? Or these two? Well, if this is a 6, that's a 7. Okay, if this is 6, 5, 4, 3, 2. 4, 5, 6, 7, 8.
Well, and the 5, 6 in column 3 makes that as, yeah.
7,
So that's now
4,
the 7, 8, 9.
2, 8, 9, 7. But then this couldn't do 5, 6, 7, and you can't put an 8 before a 7. And actually, the 8 there, this would have to be a 5, but that's a
5. Right.
Okay, how did we get there? That was from assuming that this one was the 6.
Right.
So 6 is out of that one. So then what if this was 6? 5, 4, because this has more options in this column.
Right.
But then this is going to be 4, 5, 6, 7, 8. That gets forced anyway. We get 9, 7 pair. 5, 6. This is 4 or 5.
3 or 4 below it.
4, 2, or 3. But
it can't be
above
3.
forces that to be a 2. Three, 4, 5.
Okay,
5,
if we look at
6.
box 5, there's a 7, 9 pair, and there's a 6. So that one becomes an 8. And that becomes a 5.
4, 4. 3 is out. 5, 6, 7. The 7 above it is out. The 5 over there is out. So that becomes a 6 before 5, and before that's a 4. Okay, is that the only way it works? That was assuming that that was the 6. So can this not be a 6? 6, 5, 4, 3, 4, 3, 2, and 2. Well, regardless of which of these two is 6, those two ended up being 2s. Because if this is 6, then that becomes a 2,
Right.
and that became a 2. But if this is a 6, you get 6, 5, making that a 4, 3, and a 2. So we get 2s in both of those. And of course, if that's a 6, then that's a 3. 4, 5. We get 2 and 3 there. 3, excuse me, 4 and 5. So apparently that's a 4, a 5, a 6, a 7, and an 8. 8's out, 6 is out. How did 6 come out? Because 6 is right there. So that's 6. 5, 4, 8, 9, 7. 6. Wait, hold on. 6, 5, 4. Oh, because the 7, 9 pair takes a 7 out, that's forced to be an 8. You can't follow an 8 with a 7, so that's 9. Okay. 5, 7, 4.
Hey, there are 2 8s in the Fistamafel.
I know that because of the placement, I have 2 2s as well.
Right.
That I'm going to have a 2 here and here, because this one rules it out of this one, and the 12s rule it out of there. Then the 2 8s that you mentioned, they can go anywhere.
Yeah. But one of the lockout... Yeah. Column 3.
These have to be. Oh, go ahead. Sorry.
Column 3 is left with 1, 2, 3, and 9. Well, 3 and 9 have to be in box 1.
And you can't put a 3 there. You can't put a 3 there. Because if you did,
right,
that 2 would be the only option. So that's forced to be
Column 7 is left with 1, 7, 8, 9. And that's not helpful. Okay, never mind.
Not helpful yet. Well, these two are going to have to be 1, 8, and 9. And we know 1 is one of these two, so we can actually take it off of those. Which 8, 9 pair forces a 1 there. 7, 8, 9 actually finishes the rest of this box. 2, 4, 5, and 6. 2, 6, 5.
Row 3 needs 6, excuse me, 6, 7, 8, 9.
And we know 9's not here. Yeah, the 5 is what forced these to be the way they are. 3, 9, and 4, 8, because 5 removes the 7 as a possibility. And then this 4 is what fixed the 3, 9, and 4, 8 orientation.
In box 3, we know 3, 4, and 5 have to be inside the lockout.
So I have to place
But
a 1
we don't know
here.
if it's, yeah.
And I guess
But
if
we don't know
3
what the
has to
fourth
be
one
in
is.
there,
Yeah.
if 3 has to be in there, and so does 4, then 6, 7, 8, not 9.
Column, or box 9. Yeah.
Let's look at column 4.
1, 2, 3, and 7.
2. No, 3 and 7 are both out, and that 1 fixes those. So we can probably do something similar with column 6, 3, 4, 5, 7, and 2. And we don't have 1s in here or 6s down here, and this one's not a 9.
Might as well finish row 1, 5, 6, and 8.
And that's not a 5, is a that. So the 6, 8 pair places the 5 here, and 2, 6, 7, 8.
And 8 can't be on the left because of the 4, 8, and the 12.
Right. And that actually places our 6 here. Takes 6s out of the rest of it, places an 8, a 9, a 6, an 8, a 9, a 7, and a 6. That's a 2, that's not a 2. And we don't know which one of those is 7 or 8. Those aren't 6s, those aren't 9s. This not being a 9 makes that 9 and those not. A 5, 7 pair means this is an 8 and a 6. Four, 5, 2, 6, not 9s. 1, 2, 8, 4, 9, 1, 7, 8. 3 and 7, 3 and 9. 7 and 5. And that should be. So we've got 2 2s, 2 more 2s. A 3 and a 3. 2, 3 4s. 1, 2, 3 4s. A 5. Another 5. And a third 5. 2
2
pairs of
sixes.
6s. A 7. An 8. Another 8. A 9. This 3 I missed. And that's those. Of course, that's a little less impressive, seeing as I went through. I used the fact that those all had to be paired with what was up there
Right.
to do a significant amount of it. But anyway, let's finish. I'm going to do this box first. So 1, 7, 8, 9, and that one's a 9. That one's a 7, a 1, and an 8. And 1, 2, 3, and 9. 3, 2, 9, 1, 2, and 3 to finish the puzzle. And maybe we can find this one on Logic Master Sure. Looks like it's right here. Yep, that's the right one. Row 8. Very nice puzzle. And is it on the easier side of average? I guess the Fistmafel ring is like one of those things that you have to know about. Is it possible to do this puzzle without the Fistmafel ring? I don't know. So, I think, because of the fact that you have to know that automatically makes this a hard puzzle. Because I think there are some parts of set theory that aren't automatically hard. But like the Fistmafel ring is a it's one of those tools that you need that if you don't know about it, it's really hard to come up with it on your own. I wouldn't call it impossible, but there's a reason it's called the Fistmafel ring. And Fistmafel is known for some of the hardest Sudoku puzzles, at least from my understanding. And we've attempted a couple of Fistmafel's quite difficult puzzles, and they are no joke. So, yeah, I don't know if I'm necessarily being very specific, but I don't know. I think the fact that it's one of those tools that's not intuitively obvious, that I'm gonna go with this being a hard puzzle. It's on the easier side of hard because like once we got a lot of that going, like a lot of it just sort of fell out. We just had to navigate this part, and that wasn't too difficult to do. So yeah. Oh, I guess something that should have been obvious is that this could not be a 2. Like with the Fistmafel ring, is that this could not be a 2 because none of these could be 2. And if that was a 2, and we had a second 2 somewhere, one of those 2, that it would break this side of the puzzle. So if that was a 2, it was the only 2. But I think just simply looking through the 6s was the more important part. Yeah, I don't know if 2 2s was forced anywhere. It doesn't matter. Yeah. Do you have anything else to say about this puzzle?
Nope. I think you got it all.
Alright. Then, I want this real quick. Okay. Then, I want to go to the next puzzle, and that is going to be, Abyssus?
Sounds
Most
reasonable.
likely. By Gerhard 1963. Normal Sudoku rules apply. Each row, column, and box contains one doubler cell. Using each of the digits 1 to 9 once each, the value of a doubler cell is twice that of its digit. In a cage, digits cannot repeat, and their values sum to the number shown. There is a doubler cell in every cage. Neighboring values along a navy orbital whispers line must differ by at least 8. Values in cells separated by a black dot are in a 2 to 1 ratio. Values in cells separated by a white dot are consecutive. Not all dots are necessarily given. Okay. There's a doubler cell in every cage. The fact that our orbital whisper lines can have a doubler on them makes them no longer automatically 8 and 9, and they don't even have to be
Need 1 and 9.
right 1 and 9.
Oh, and they.
Because you can put, I mean, if you double the 9, you can put an 8 next to it.
Right.
So each row, column, and box contains one doubler. Okay. And we know that one of those 2 is doubled, and one of those 2 is doubled. But I can still put an 8 and a 1, and just simply double the 1. So how do we start this?
Well, let's go with the black dot. Because
only
all of the even are in there, so a doubler.
I mean, if you doubled one of them, let's say the one on the right was doubled. How would that work? They're in a 2 to 1 ratio.
Well,
I think the only way you can double it is if you made that a 1 and you doubled it to connect it to a 4, because then that 1 becomes a 2. But like, I guess I could go 2 to 8.
Well, there's one doubler in each cage, or in each box.
Yeah.
But there's also one doubler in each cage. So the doubler for that box is in that cage.
Yeah. So if I said that this was the doubler, I could place 1 in it and double it and make 2. And then I couldn't put 1 to pair with 2, so it would have to be 4. And then I could double 2 to make that 4, and then I obviously couldn't do 2 again, but 4 can pair with 8. 4 doesn't work because doubled it becomes 8, and I can't put 16 or 4 again. So I could double 1 or 2, but that's still 1, 2, 4, and 8 in that chain.
Well, except you can't put an 8 in the 7.
That's true. And then we have 3 and 6. But you can't double 3. And then 5, 7, and 9 still don't work. Because even if you try to double it, well, it would just have to pair with itself. So that ends up staying as it was.
Right.
So then, okay, if this was doubled, this would have to then be odd. And if this was doubled, that would have to be odd, which would be 1 or 3. Whichever cell is not doubled in the 10 has to be even. So you can't have 7 or 9 in here. Or 5. 3, 4, 6, 8. And actually, since we know the smaller digit has to be doubled, I could double 1 and pair that with 8. I could double 2 and pair that with 6. If I double 3, it pairs with 4. And if I double 4, it pairs with 2. Okay, but it's still those digits. If this is doubled, that's 1 or 3. Which would make that 3 or 2. If this is doubled... Oh, well, I couldn't put a 6 in here. 6 is automatically out, so 3 is automatically out. The reason I can't put a 6 is because I'd have to pair it with the doubled 1, which would make it 8. I can't double 4, so that would have to be... Well, that just simply wouldn't work. So 4 is out, which means 8 is out. No, it's not. Because I can double the 2 still. If I double 1, then I place a 5 here. If I double 2, then that's 4 paired with 3. And if I double 6, or double 3, I get 6, and that leaves a 1. And so, if this is doubled, then this is odd, 1 or 3. 1 would leave 6, half is 3. 3 leaves 4, half is 2. Okay, so those are our values. Those are our possibilities. One would put 2. 3 would put 6. 2 would put a 3. If I double this 2, that's 4. That would be 3. Clearly that would be 4, which would have to pair with 8. Okay. If this is a 1, then that's a regular 2, which means that's doubled, which means that doesn't work. If this is a 2, then this would be a regular 1 or 3, which means this is a doubled 3, or a doubled 2. Well, this couldn't be a doubled 2. If that's a 2. So that would be 3 and 1. If this is 4, this would have to be a regular 2. So 2 and 4 both make this regular. 6 makes that a regular 3, but the 8 allows it to be a double 2. So the only way that this one could be doubled is if it's a 2, paired with a 3. But we don't have double 1 paired with 5, or double 3 paired with 1 anymore. So if we double the top value, if we double the top value, it's a 2. If we double the bottom value, it's 2 paired with 3, or 1 paired with 3. But a 3 is a requirement either way. This is a regular 2, that's a regular 1 or 3. This is a regular 4, this had to be a regular 2. But if that's a regular 2, that had to be 5. You can't put a regular 2 here. So 4 doesn't work. This is a regular 6, that's a regular 3. You can have a regular 3 that's paired with a double 2. 2 pairs with 1 or 3. 1 or 3 pairs with 2 or 3. No, a regular 2 pairs with a 1. This isn't consecutive. 2 with 1 with 3, or 6 with 3 with 2, or 8, 2. Okay, so I have to have 2 in here as well. Did you point at this line like 6 hours ago?
No.
By 6 hours, I mean like 10 minutes ago? Okay. What should have been obvious, and it's obvious
It's
now
1, 9, yeah.
Because the doubler has to be
in the cage.
So we can't double either of those values, which means they have to be regular values. So let's take out 1 from all of that. So this cannot be a regular 2, because if it was, it would have to be a regular 1. Or a 4, which we have shown that it doesn't work as a regular 4.
And that can't be a double 3.
Right. Because if that's a regular 3, that's a double 2 for 4. 3 and 4 make 7. Otherwise, we have 8 paired with double 2, which is 4, so that works, and 4 and regular 3. Okay, so we no longer have doubled 1 paired with 8. So we can have doubled 2 paired with 6, doubled 3 paired with 4, or doubled 4 paired with 2. Three pairs with 6, but that would put a 2 or a 4 here.
What do you mean 3 pairs with 6?
In the 10. Oh, wait, that's not how that works. 3 pairs with 4. Right, okay. 3 pairs with 4 in here. So that
6
would
pairs
place,
with 2.
So if this is a 2, if it's a regular 2, then I get a 3 here. If it's a doubled 2, then it's a 4, and I have 6 on the other side. So then I can put 3 or 5. If this is a regular 3, I'd have to put a doubled 7. If it's a doubled 3, then it's 6, pair with 7 or 5. If this is a regular 4, well, that would be 3 or 5. And if it's a doubled 4, then that would be 7. And then 6 has to be paired with 5 or 7. The doubled 2 on top. Okay. So this has to be even. Because if it's a 3, we know the 3 is doubled. We can't pair a regular 3 with a 7. Or with a 3.5 to make 7. We know that these are both regular, which makes them a 1-9. And the same here. Those have to be a 1-9.
Right.
Because those two have to differ by 8, and they're both regular. Okay.
Okay,
So,
well then the doubler has to be on the line there. And it can't be on the right, it has to be on the left. Because the doubler in that column is in box. So that's a doubler.
okay. Now,
and you can do the same thing with the other line in box 6.
So does that mean that these two have to be doublers? Because let's say this was, let's just say it was a 2. It can't be a 2. Let's say it was an 8. Well, actually, that can't be. Well, I could double an 8 here. And that would be 8 away. But, okay, let's just say that could be a 2. Let's put a 2 here. Let's say this one's a 2. This has to be at least 10 now. And the only way to make that 10 is to double it.
As if it's double it, right.
So that doubles that and that. So this cannot be a 3 anymore, as I remove a 2. A doubled 3 would pair with a regular 4.
Well, you can resolve the
4
cage in box 8, or 7, rather.
Right. 2 paired with 3 and 6. And I guess... Right. Because this had to be 1 or 3. Because this is odd. And this... I guess it was 1, 3, or 5. The 5's removed by the dot. 1 is removed by this, so that's forced to be a 3, which pairs with a 6 and 2. Okay, cool. First try.
Well, and we can find the doubler in boxes 1 and 9. And in 5.
5's the center digit. 1 is going to be here, and 9 is there. Okay. Those two are irrelevant, but that's fine. These are 1, 9. Yeah. Those should have been a lot more obvious, as well as those. That was a miss.
Right. Box 3, the doubler, can't be a 6.
True. We know that these are minimum 10, so 5, 6, 7, 8, 9. No 6, no 6. We know that these two aren't 9, because we've got 9s looking at them. Same as those two. Now...
Well, 5 doubled is only 10.
Yeah. Oh, this one
right. Which would
is
be a
minimum
2.
4.
Can't be 2. Right.
4 and 8 is 12. So the 5 is out here. But this can go all the way up to 8. If I could have put a 9 on those, I could have... If this could have been a 9, then that could have been a 9. But we don't have to worry about that. Because 9 doubled is 18, and 18 minus 8 is 10. So it allows 2 9s to be based there. Four, 5, 7, 8. That's helpful. But I'm going to put it in there. Put it there anyway. I just guess this goes from 2 through 7. That's all the digits, so I guess it's 6 digits. Doesn't really matter. trying to think what would be useful next. The only thing I can think of is perhaps these crop dots, but I'm not sure which one would be most useful. I guess something in this region is probably going to be the most useful because I've got more digits over here. So perhaps I look at this one. 1 and 9 is off of both of those. 2 and 3 means 2 is not allowed here. That's it. That doesn't feel useful. 6 is out. And so 7 would have to pair with 8 to break that. But I think everything else is just fine, so I mean, I guess 1 and 9 is off of the top, but not enough. Not enough. Where can I put 1 and 9? It's not there or those two. And they can't be stacked on top of each other. They have to be corners.
And the doublers use the digits 1 through 9 once each.
Oh. So this
now
can't be a 2.
Out. Right.
So that was 4, which paired with 6. So that's not a 7 anymore. Because this is regular. Yeah, I have 1, 3, or 5, but that's
and
not
in
there.
The ones in boxes 2, 4, 8, and 6 contain the digits 5, 6, 7, and 8. So 1, 3, 4, and 9. Yeah. What about, yeah.
If this is a 3, that's a 4,
and in
which would be a
box
5.
5, can't have 1 or 9 in it. The doubler, because of the 1, 9. So that's 3 and 4, so the other 2 are 1 and 9. The boxes, yeah.
So that helps up here because we knew that the 1, 9 had to be catty corner. I think the same thing is true down here because these two take out the center. Those two take out those two. And if I put another 1, 9 here, that breaks that one. So those are out. So that's 1 or 9. Which makes these 2 or 8. This one can't be a 2. So that's 8, 9, 1, 9, 1, 9, 1, 2, 1, 9, 1, 9, 9, 1, 9, 1. 8 is out. 1 and 9, 8 is out. 3 has to be one of those two, because if this is a 3, it gets doubled to become 6, plus 4 makes 10. Well, 4 would have to pair with 5, because that's a 3. If this is a 4, doubled makes 8, leaves 2, and then 2 can't pair with 5, so that becomes a 3. So 3 is one of those two. I'm glad you found the 1 through 9, because I'd forgotten that rule. 1 and 9. This can't be 2 or 6. And if this was an 8, it would pair with a 7. So 8's out of both of those. If this was a regular 8, plus 8 is 16. Well, 14's not enough. 7 plus 8 is 15. So that would have to be an 8.
They would have to both be 8.
No, if this was a 7, that could be 8.
No,
But if this was
both
an 8,
doublers.
that would have to be 8.
If that's
Oh, right. And that's not allowed.
Yeah, I wasn't very clear. Sorry.
One of these
6 and
two is a
8
5.
is 14. So 7 and 8, yeah. Well, if
That means this has to be a 2.
yeah,
Because
which
one of
resolves
those
the
two.
yeah, it has to be 5. So which resolves
4, 3, 5. Not a 5. Is a 5. So that's also a 2. One of those is an 8, but that's less helpful. Maybe 3. Pairs of 5, 6 and 7 pair with each other. Four, I guess I should put 6. 3, 4, 6, 7. 4, 5, 6, 7. 3, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, and 8 leaves a 7. 5, 6, 7, 8. 7. Not a 5, not an 8. 5, 6 pair makes that an 8. Not a 7 nor a 5 or 6. 3, 4, and 2 is left over. That's not 2. So that's an 8. That's a 3. That's a 2. 2, please. Not a 3. Those two aren't 8 anymore. Six pairs with a 7. 5 with 4 or 6. Okay.
Oh. Okay,
Oh,
in box 8, the bottom crop key can't be 6, 7.
because those would
So
be a
it
pair of
can't
4s.
right. So it can't have so it's not yeah, it's not 6. But that means since the bottom one is either 3, 4 or 6, 7 or no, or 7, 8.
3,
Never mind.
4. It means 6 has to be one of those two. Because,
Okay, that's what I thought I was saying.
yeah, because a 3 or a 4 means that's a 6, 7. And a 7, 8 means it's a 4, 6. This is
Right.
5 regardless. 5 can't pair with 7. That's a 6. That's not a 6.
Okay, that's what I was trying to get to, but then I thought, well, wait a minute. No, did I just Okay, I was right in my thinking.
I mean, that seemed reasonable to me. Because if this is 3, 4, then that would have to be 6 and 7.
Right.
And if that's
Oh,
7, 8,
I think
then it's a 4,
I
6 pair. Yeah.
I think what stopped why I had stopped there was like, oh, wait a minute, 4 and 6 aren't consecutive, but then there's no crop key between them.
Yeah.
That's yeah.
4, 5, 6, 7. 4, 5, 6, 7, and 8.
3 could be placed in box 6. And it can't go on the Kropke dot because it can't pair with 2 or 4.
Oh, and then place 4 there. That gave me 3.
So column 8 is left with 3. Geez, 6, 7, and 4.
Or that one's not a 4, so that one is. And 3, 4, 5. 6, 7, and 8, I think. Looks like that's right. 6, 7, and 2. Apparently this
Box.
isn't 4 or 5.
Yeah.
So that's a 6. 6 plus 8 is 14. So that's not a 6. We get a 7, 8 pair. Places a 6. Uh, 7 and 9 means that can't be an 8. 4 and 5 means that's 3, 4, 5, and 6. Apparently not a 3. If this was an 8, well, that would go all the way up to 8. 3, 4, 5, 7. Of course, we can't put 2 8s next to each other. So 1, 2,
There's a
4,
7, 8 pair in that row.
7, 3, and 6. 2, 3, and 6. Go all the way across. Not a 2. 3, 6 pair places a 2 and a 6.
Box 4, the 6 comes out of the left of the Kropke.
So 7 can't pair there. 4 is forced to be there, because it's the last even digit. And also those 2 4s remove it from the top row, and then 9 force the 4 on there. 6, 1, 9, 4, 3, 8, 5, and 2. 4, 5, and 7 means that's an 8, that's a 7, that's an 8. 6 plus 8 is 14, so that's allowed. 3, 4, 5, 6, 7. Three, 4, 5, 6, 2, and 7. Not helpful. Do I have ones in the middle box? 2. Less helpful. 2, 5, 2, 5, 7, 8,
6.
7. 6 has to be one of those two. We've got 6s like that. What about 9? 9's ruled out of bottom and side. 9 isn't a 4, obviously. It's also ruled out of the middle, and this 9 was a that, so there we go.
Is that all the 9s now?
I think so. 1, 2, 3, 4, 5, 6,
Yeah.
8, 9.
Okay. Yeah.
9, 1, 8, 6,
8
7.
can be placed in box 2.
Here, not 1, not there, so that's an 8. Takes 8 out from down there. This is on, so that's even. 2, 3, and 7. That's not a 7. 4, 9, 1, 2, 6. Not a 5, not a 7. Five has to be one of those. It's the only odd left. That's 5, that's 3. If that's 4, if that's 5, then that's 3. If this is 5, that's 4 or 6.
That can't be 4.
This can't be 4?
If that's 4, then above it becomes a 2 and a
There goes
3,
3.
and nothing for the next one to the right.
Okay.
3, 5,
If
6 triple in box 2. Anyway, sorry.
I guess that answered the question. I was going to ask if this had to be a 3 or a 5, and how that would impact the 2, 4 around it, but it seems resolved.
Column 5, 3, 6, 7 triple.
So that's 5, 7, 3, 6 pairs with 5, places a 4, 6, a 3. 7 pairs with 8, 6 pairs with 4, that's a 3, a 4, 7, a 5, 4, a 3, a 5, 2, a 7, 2, wait, hold on. Oops, almost messed it up. Not a 3, not a 5. That's a 2, not a 1. That's a 7, that's a 2. 8, 5, 7, 6, 3, 2, 4, 7, 8. Although I think I didn't actually mess that up, because I think I said 2 was 7 and a 2 there.
I'm not sure. I'm
Um,
not sure.
Yeah, because if I decided to put a 7 there, then those would both be 2s, and
Right.
that would have been broken. So, I was looking forward in the puzzle there, and not accidentally missing the.
Well, and when you place the 5 in box 2, you
Mhm.
didn't immediately resolve that Kropke dot.
Oh yeah, I should have done that too.
But it doesn't really matter. It got there in the end.
Yeah. The scatter of all of the things that are happening. Digits on the positive back. Positive is increasing. Oops. Copy. Oh, it went the wrong way around. No. 573, 54, 34, 76. Congrats. Okay, cool. Very nice. And then, which I guess we knew the puzzle was correct because of that. Difficulty. We definitely missed the 1.9s here. So that took us a little bit longer because we missed the implications from that.
Right. And the delay in remembering that. Oh yeah,
and the unique values.
Right. For the doublers.
I guess I kind of want to just go with average. Fine, like once we remembered this, it was fairly easy going for a little while, and then it just became sort of nitpicky. But none of the nitpickiness was necessarily difficult. Working through some of the possibilities was a bit tricky, but I don't know if I just sort of went through them slower than I should have. I'm just going to go with average on that one. But, yeah. Alright. Then, I'm going to check and see if we've got an Electron puzzle we can take a look at. Nope. Which means I am going to go grab another one. Oh, actually, it is almost 10. So I guess I'm not going to do that.
10 till.
Alright. Then, since it is almost 10, that is sign-off time. Because I need to go to sleep. So
I do as
go
well.
to work tomorrow. Work is important as much as I wish I could just keep doing Sudoku puzzles, but I don't have enough viewers for that. Alright, then
But is work important or simply necessary?
the answer to that question is complicated. In our current system, work is necessary. It is also important, and in a system that I would prefer we had, it would still be important. No, work is necessary. We have to do work, regardless of whatever system we want to see. Work is still a necessity because we still need to get things done. So, like, I don't know. I work in like file management, so there's a lot of my job that could be made a lot more efficient. But you work in logistics, so like in a job that could be like automated somewhat, but I think where you work and how it's laid out would require significant effort to automate.
Oh yeah, it would have to start from scratch with the automation in place going forward.
Yeah. But I mean, even if we wanted to, the system that I would want to see, I would still want people to do meaningful work. So like stuff that could be automated, paperwork. Cause like I'm a file clerk at my job. Like some of that paperwork that could be automated. So like I don't necessarily find a whole lot of meaning in my work, but it pays bills. So the system that I want to see would automate some of that, so I can do something that I would find a lot more meaningful, something a lot more creative, or researching stuff that could be done. But yeah, work is a necessity, even if we spend too many hours working. Yeah, I don't think work's avoidable, and I think a lot of people would prefer to have some type of meaningful employment than to just sort of do nothing. Because I know that I've just sort of been bored occasionally, just sort of like, I'm doing nothing, when I was unemployed for a long time. I don't know. Do you have thoughts on that one? I don't know if the question was meant to be as thought provoking as it ended up being for me, but
It's definitely a necessity. Important? No. Some jobs, yes, are important.
yeah, there's definitely ways that we could optimize our time spent in work so that the work that we do is a lot more meaningful. But that is for more political focused streams. I will hopefully start doing soonish. But in the meantime, right now the things that are scheduled are Sudoku on Mondays and Tuesdays at 8 p.m. Eastern Time. Outward on Saturdays at 7 a.m. Eastern Time, and the secret political stream will probably be on Wednesday at 5 p.m. Although I need to check with the person that I was going to stream with to see if they wanted to stream this week or start next week. But aside from that, make sure to do all of the fancy YouTube engagement stuff, like liking, commenting, subscribing, ringing the notification bell, and sharing the video. I greatly appreciate anyone who does all of those things, and especially everyone who watches the videos. Thank you so much, and have a wonderful day.